right, now we're going to continue with the vertical expansion and compression part of the transformation of the function. So if we have y equal to f of x, then if it's transformed by the a f of x, there will be certain characteristics that we need to figure out. All right, and this part right here is important because this a is actually showing up as a coefficient or as basically a leading number, leading constant in front of the function. All right, and I said I want to remind you of the quadratic function because that's a function that you are familiar with. So if you remember y equal to a times x minus p all squared plus q, this was the vertex form. This a vertical expansion or compression for the value of y. So, and we can go ahead and talk about that. First thing first, let's get this out of the way. What if a is negative? If a is negative, then we remember, if you remember that, the graph just flips over the x-axis. The graph of the parabola opens down, if you remember that. So that graph opens down, and you remember that. So that graph opens down. That means, basically, this is what it means. It means reflection over the x-axis. Now, this reflection over the x-axis applies for every function. Doesn't matter what the function is. Okay, so let's go to Desmos, just make sure that we know. So here's my graph of y equal to x squared. That's the original parabola, right? And if I punch in negative in front of it, I didn't put any other number, just didn't want to confuse you right now. But look what happens when I click initiate that graph, flips over the x-axis. You knew that. It's simple as that. Okay, so every time that you have a negative in front, the coefficient is negative, graph reflects over the x-axis. All right. So now let's look at what happens if a is in between 0 and 1. That means it's a fraction. And you remember that too. If we had y equals 1/2 x squared, you remember that 1/2, what it does is that it makes the vertical value of y shrink or compresses it by a factor of half. Okay, and if it was greater than 1, so for example, if you had y equals to 2x squared or 1/2 1.5x squared or anything that is greater than 1, this became the vertical expansion. So this one was vertical compression, and that is vertical expansion. And we say that vertical compression or vertical expansion by a factor of whatever this number is, a. Okay, so in this case would be 1/2. In that case, the vertical expansion would be by a factor of 2. Let's go to Desmos and take a look at it. So here it is. I have this table has set up. I created, actually, let me change that to 2x squared so that you can see. All right, so let's look at what happens if we have the table set up. So here it is between the y equal to x squared and 2x squared. Look at the values of y. They are all doubled, okay? And then you can see on the graph, okay, that if this was the coordinate of 1, 1, when you have now the 2 in front of the function becomes 1, 2. That's the new coordinate, and that's where you get here. All the y values have been doubled, okay? Now in comparison, what happens is, what if I click on, let me click that and then initiate the half and then graph that. Here is the graph, and look what happens between the x squared, the original function, and then the original function value, which is y values. Now they're all halved. You see that? That means the graph has kind of expanded, this vertically shrank. That's what happened, okay? So originally, if this was the coordinate 2, 4, which is right in that coordinate 2, 4, when you have a half times x squared, it becomes 2. The 4 divided by 2, that's 2. That's what this is. And all of these y values, the function values, they have been halved. So we say that is a vertical compression. All right? So for a horizontal expansion and compression, we are going to deal with the number or the coefficient that is in front of the x. So if this was the original f of x we have right here, then what will happen is that the new transform function will have a b in front of it, right there inside of the bracket, just before the x, not in front of the function, not like the vertical expansion, but in front of the x value. So I'm going to give you a couple examples of that, and then you'll see what is happening. First thing, let's deal with the negative. Now remember, if it was in front of the function that was a vertical reflection over the x-axis, well, if b is negative, the simplest thing is basically you will get reflection over the y-axis. So the graph flips over the y-axis, okay? And the best way to describe that is going through different functions. So let's I'd like to give you an example. So let's suppose we have this green graph. The function that I have put up here is the square root function. You have probably seen that in grade 11. So this is the graph of it, and notice that anything, the x value here is a restriction on the domain, cannot be negative because you cannot have a negative radicand in here. So that's one of the restrictions of the domain. But look what happens when the coefficient of x is negative. So this is the negative in front of the x, okay? So look what happens. We said there's a reflection over the y-axis, and sure enough it does. It's a mirror image. It's almost like that the y-axis is a mirror. This happens for every single graph. Now, some graphs are very symmetric. For example, quadratic is very symmetric, and because it's symmetric and it doesn't add the power of the 2, it doesn't make a difference. So here the example, y equal to x squared, we know what that is. Now if I put negative in front of the x, and now remember it has to be the bracket now because that negative belongs to x, and if I engage that, it doesn't make a difference. It's just the flip that happens from this point to that point and then flips over again. It's a mirror image. It doesn't make a difference, and all points map, and it will give you the same function. This is the one of the only functions. Any of the even functions, even function, or when the polynomial degree up here is even. That's what's called even function. It's not all of them, but most of them, they do map very closely. Okay, so in this case, look at the two graphs. The original graph is the square root of x is here, and the new graph is the square root of 2x. I put a 2 in front of it, okay? So let's see what happens when we have that. If we want to keep the y value the same. So in this case, you can see that the y value in here is about 0.75. Let's suppose it is. But look what happens when we introduce the 2 in front. The y value is the same, but the x value went from 2 to 1, okay? So this is now the y value, actually, the x value has been halved by putting the 2 in front of the x. For the same value that we're going to get for y for both, the x value has to be half. So it turns out that whenever you have a value in front that is bigger than 1, you are going to have a horizontal compression by that factor. So now let's look at what happens if we have a value of a that is between 0 and 1. So I typed in 1x over 2 is under the square root, and I graph both of them, okay? And I want you to see what is happening in here. So if we keep, remember, we want to have the same y value. So if I want to have the same y value, let's suppose that we want to have the same y value, which is 2 right here. So that's the y value for the value of x. Okay, so in this case, so the red graph, so the green graph is our original graph, the red graph is the transformed graph value. So the x value now is 8. It went from 4 to 8 to get the same y value. So this 1/2 what happened is that it made the value of x multiplied by 2. So 4 to 8, that is double. So this half made that horizontal expansion by a factor of 2. Is kind of opposite of that. Okay, so now let's go ahead to the notes and write it out. So here it is. If we have a b value between 0 and 1, we got a horizontal expansion by that factor of b. Okay, remember that is a fraction. For example, if b is 1/2, the expansion will be by factor of 2. Okay, it's very important that you see that. But the other one, if b is greater than 1, let's suppose b is 2 or 3 in this case, just to make it different, we're talking about compression by a factor of 1/3. Okay, a third of the original. That's just the horizontal, only the x values. These are all affecting, okay, remember, affecting the x values only. Okay, so in terms of the coordinate points, if we have a coordinate point that is x and y, and we want to know what happens that goes through the transformation of f of, let's say, a times f of x, well, the new graph will end up being x comma ay. So a becomes the multiples of y, and that's a vertical expansion or compression. But if you have xy and it goes through the transformation of the horizontal transformation of this, then x value changes, and that becomes 1/b times x comma y, because y doesn't change. That is the transformation for the horizontal and vertical expansion and compression.